Welcome everyone. Today we will explore how models are used in system design and development. Models play a crucial role in simplifying complex systems, improving communication, and organizing processes effectively. We will begin by understanding the purpose of models, why they are needed, and how they help new systems during development. Then we will move on how models are represented with a focus on tools like Unified Modeling Language (UML). Next, we will discuss the different perspectives in modeling. This includes external interaction, structural, and behavioral perspectives, all of which provide a unique insights to the system. We will then delve into interaction models, which focus on cataloging functional requirements and highlighting communication issues. From there, we will learn about the use cases which outline tasks involving users and system interactions. We will also touch a sequence diagram which map the sequence of interactions between actors and the systems. After that, we will explore behavioral models to understand how systems respond. We will further explore the data flow diagrams which show how high-level data processing and finally discuss state charts and transition tables which models system states and transitions in both visual and textual forms. By the end of this presentation, you will have a better understanding of how models simplify system development and facilitate communication. Models help us simplify reality to better understand and communicate systems during various stages like requirements gathering, system design, and program design. They are especially useful in complex projects where a single perspective is not enough. For instance, some models show what the system does, others show how it works, and some help refine the design. Large projects benefit from formal models to ensure clarity and avoid miscommunication. Most importantly, models are meant for human understanding, bridging gaps between developers, designers, and the stakeholders. Models are commonly represented by Unified Modeling Language or UML. These include diagrams and specifications tailored to specific needs such as facilitating discussions or even generating code. But why not rely on code alone? Models offer simplified perspectives focusing only on what's relevant at the time, while the code includes platform details and abstractions. For example, UML diagrams can help visualize interactions or relationships between them, easier to understand and discuss the raw code. Now let's discuss about the modeling perspectives. There are four main perspectives when modeling systems. External perspectives, which focus on how the system fits into environment. Interaction perspectives, which shows how users or components interact within the system. Structural perspective illustrates the organization of the system components and the data. Behavioral perspective demonstrates how the system responds to events or changes over time. These perspectives together give a complete picture of the system and its operations. Interaction models are key for understanding functional requirements. Use case diagrams focus on specific user tasks and interactions such as student taking an online exam. Sequence diagrams, on the other hand, map out interactions between systems, helping identify potential communication issues. These models ensure all the interactions, whether human or system-based, are clearly understood and planned. Use cases break down tasks that involve systems interaction, making them easier to analyze. Each use case includes the actor, their goal, the trigger, preconditions, and the expected outcomes. For instance, in an online exam system, the actor is the exam taker, logs in, selects an exam, answers questions, and submits the exam. Alternative flow covers scenarios like resuming a saved exam, while exception handling failures such as login errors. This clarity makes use cases invaluable. Sequence diagram illustrates the flow of interactions between the actors and the systems, highlighting causal relationships and communication protocols. For example, a user logging into application and receiving authentication feedback is mapped step by step. These diagrams are particularly useful for understanding and documenting protocols or workflows. Behavioral model focuses on how the system behaves dynamically during execution. Data-driven models such as show the sequence of processing steps from input to output, while event-driven models capture how the system reacts to triggers or events. These are especially useful for real-time or embedded systems where response to specific inputs are critical. Data flow diagrams provide a high-level view of how data moves through a system using symbols to represent activities, data, and sources. While these diagrams are excellent for understanding the overall flow, they often need to be complemented by low-level specifications to detailed logic or decision-making process. State charts model the system states and how it transitions between them based on triggers. These are ideal for systems with defined states such as user interfaces or real-time embedded devices. Transition table provides a textual way to represent transitions, making them great for scenarios with dense or complex tools such as physical button interactions. Thank you for watching, and I hope this helps you in your software development journey.